Let's start by taking a look at Solid Edge working in a traditional history-based method. Here we use the technique of selecting the feature we would like to create and then generating a profile for that feature. In our example here with the rectangle, some alignment constraints will ensure everything stays symmetric about the centre of the part's origin. Once this is finished, we can define the extent we require and create the 3D geometry. Moving on, we can select another extrusion feature and draw a profile on the top face of the part. Then once again, define the extent. Repeating the same process on the other side of the model allows us to create a similar but slightly shorter extrusion. From here, we're going to select the end face of the part to draw an arc. Notice that the 3D and 2D environments are separated, which means we are either sketching or using 3D commands, never both together. Using the hole command will allow us to generate simple, threaded, countersunk or counterbored holes. Again, notice that the 2D and 3D environments are separated. Selecting the round command allows us to smooth off some sharp edges. Finally, we want to generate a slot right through the centre of the part. As such, we need to switch to the cutout command. Then identify the face and once again draw an appropriate profile for the shape of the cutout we would like to create. Here we are adding some relationships as we go to ensure that it stays symmetrical about the centre of the part. If we find we need to make edits to the geometry we've created, in a traditional history-based modeler, this involves having to adjust the underlying profiles that control the geometry. We can either do this directly in the profile, as we can see here, or alternatively, we can do it dynamically, as we're going to see now. Either way, these changes involve the model's history having to recompute. Not a problem on this simple part, but will definitely be a problem on a more complex part. Also, if we need to control any of the geometry with dimensions, these must be placed in the features profile or sketch, since it is the profile that ultimately controls the resulting solid model. Once again, these edits require the history of the model to be recomputed every time a dimensional value is changed. Finally, in order to add draft or angle to any of the faces, requires us to add additional modelling features in order to achieve the desired result, as can be seen here whilst we draft the two side faces of the part. And also the end face of the part. So now we have our finished part, and we can see the additional draft features that have appeared in the model's history. The next video will show how to generate a similar part using the new synchronous method.